right, moving on to blocking. So blocking is not required in an experiment, but it should be done in specific situations. Sometimes attributes of the experimental units that we are not studying and that we can't control may nevertheless affect the outcome of an experiment. If we group these similar individuals together and then randomize within each of these blocks. So a block is like sort of like stratified. It's making a group of individuals or experimental units that are all alike in some way. We can remove much of the variability due to the differences among these blocks. And what's important is that you complete the full experiment within each block. So each block would get all of the treatments. It's kind of like just doing an experiment on more than one group of people. So for example, with the dogs, let's say the breed of the dog could affect whether they get sick or not. Maybe bigger dogs tend to get, or smaller dogs tend to get more sick off this food than bigger dogs. So we might first separate all of our dogs into small breeds and large breeds. And then the small breeds would get the new dog food and the safe dog food. And the large breeds would also get the new dog food and the safe dog food. And that way the breed is not mixed in both groups, and therefore we can't see that effect that breed has. So that's what blocking is. Blocking is an important compromise between randomization and control, but unlike the first three principles, it is not required in an experimental design. Alright, so here's another for example. We're planning an experiment to see whether the new pet food is safe for dogs to eat. We'll feed some animals the new food and others a food known to be safe, comparing their health after a period of time. In this experiment, how will you implement the principles of control, randomization, and replication? So I've already kind of talked about control. For control, you're going to want to make sure that dogs get the same amount of food, same amount of water, same amount of exercise, same care. Might sound silly, but if some dogs are hugged and loved and petted on, that could be different than dogs that are just thrown in a kennel and sitting and cowering in the corner all day long. Anything else that you can possibly think about. Same water, same exercise, same care, same times out of their kennels, that would kind of go in care. Just anything you can possibly, same treats, anything you could possibly think of that could be a source of variation or could be a source of why one group got sick and the other one might not. You need to make sure you control that. Randomization, how are we going to implement randomization? We're pretty much just going to randomly assign dogs to the treatment groups. Our treatment groups are our two different types of dog food. You could do this with a random number table, a random number generator, any way you can randomly assign the dogs to the groups. Replication, simply we will have multiple dogs in each group. And you want to kind of use about equal size sample sizes as much as you can. I mean, if you have 2 treatments and you have 11 animals, then obviously you can only split them 5 and 6. But you don't want to do like 2 and 9 or anything like that. It's equal sample size as you possibly can. All right, you can diagram an experiment, and this is quite often what you're sometimes asked to do on an AP exam, is to draw a diagram or explain how you would conduct an experiment. And you can either explain it out paragraph form in words, or you can use one of these diagrams. The following diagram emphasizes the random allocation. So make sure that that is stated in your diagram. I usually kind of write it across these lines right here. That's usually where I write it, that I'm going to randomly assign these subjects into groups. That's important, that it's very clearly stated that you're doing randomization into groups, and then which groups get which treatment, and that you come back together and you compare. And you should state your response variable here, saying what you're going to compare. So you're kind of starting, we usually start with our experimental units, and then we split out from them randomly into our groups. So if you have more than 2 groups, then which groups get which treatment, and we come back together and we compare our response variable.